Okay, can you hear me? Okay, this is bigger than expected. Okay, let me just make that bigger. Do you see that in the back? Yeah? Okay. So let me just make it like this. Okay. So the last language I want to present today is Idris, and Idris is on the far end of statically typed programming languages. So it has an even stronger type system than Scala that Valentin presented today. And this can help us basically give a lot of guarantees about our program and make it basically safer. And I just want to start directly with some basic syntax so you see how that looks like, and then we'll see a little bit of the cool things that we can do in Idris. So let me just define a variable x, and we can say x is of type integer, for example. And in Idris, we write the type the implementation below the type definition, so we can now assign x the value of 5. So that's just a basic variable. And, oops, let me just move a bit over here. Okay, good. Okay, so now let's define a little function. Let's call it length to calculate the length of a list. Okay, and length takes a list of, for example, integers. So we have a static typing here as well, and we return an integer. So now in Idris, I can basically ask the compiler to give me an initial implementation of that length function. So by hitting \d, I get an initial definition. So in functional programming, a list is typically recursively defined. So it's either an empty list or it's a concatenation of some head element and a tail list. And in Idris, we can ask the compiler to do this case split. Okay, so list can be one of the two things. And by hitting \c, I can do this case split. So as you see here, we have this, where's my cursor? So we have this empty list here, or the concatenation symbolized with this double colon here. So we have the head element on the left side and the tail on the right side. And the things that you see on the right are basically holes. So in Idris, we basically develop with holes. That means that this thing, if I hit \r, it will compile, as you see here below. Successfully reloaded means in Idris that thing compiled, but I don't have to implement it yet. I can defer the implementation to later. And of course, if I at some point run that program, then I have to provide an implementation. So let's now do that. So I can say the length of an empty list is 0. And in the case of a concatenation, I just add 1 for every element. And then basically I can recursively call the length function with my tail list. Okay, so let's see if that compiles. That compiles, and let's see if it actually works as well. So let's just call this function, and it works perfect. So let's have a little bit deeper look at this list that we used. So let me just create a new variable, list. And list is a type constructor. That's what it's called. So it takes a type, like for example, int. And now we get a concrete type, which would be list int. And we can define that list int as to be, for example, 1, 2, 3, as I did before. And now this type is already quite concrete, so I cannot, for example, assign a string to that. So if I would try to compile that, then we would see I get a type mismatch. So that's already quite safe, but however, I don't have any information on how many elements are in the list. So what typically happens in programming is that at some point I have an empty list, and I call head on the empty list. And we have seen in Antoine's talk before, in Elm, they solve that with a maybe, but in many programming languages, they just crash. And so that's not really good. So what we can do in Idris is we can use dependent types, that's called. And that basically means that we can have, in the type position, we can also have values of types. And before I show you that in more detail, I want to show you one little type that we will use now, which is called the natural numbers. So the natural numbers are like integer, but basically starting from 0. And they are just like a list, they are recursively defined. So they can be either 0 or the successor of a previous natural number. So let's start with, for example, 0. As you can see, is a natural number. Or I can define the successor of 0, which would be 1, or the successor of 0, which would be, for example, 2. And in Idris, we have a special data type. It's called the vector. And the vector is basically like a sized list. So let's have a look at the documentation for that. So this is the documentation. So a vector is a type constructor that takes a value of a natural number, which specifies the length, and a type. So that's just like a list. It could be an integer or a string, and creates the concrete type. And just like the list, we have two data constructors, which would be nil or the empty list. And as you can see, this vector then has 0 elements. And the second constructor is the concatenation. So we have a head element and a tail list or tail vector of length elements. And we get back, by concatenating that, a vector of successor of length elements. So now with that, we have a stronger guarantee in Idris to basically define a sized list. So we can, for example, define a vector and say it has 3 elements and is of type int. So as you can see here, now I have a value in the type position. And in Scala, for example, that's somehow possible with a lot of magic and boilerplate. And in Idris, you can just directly write it. And now I have a special guarantee. So I can, just like before, create a list with 3 elements. This will perfectly compile. But if I, for example, just assign 2 elements to my list, then I will get a type error, which is not really readable, but it's an error. So I, so I get this error at compile time, not during runtime. Yeah? So I cannot even compile and build this program without fixing this error. Okay? So I can just undo that. And now with that, we can basically define or implement a type-safe take function. So you've seen in Joy's talk already the usage of a take function that takes some elements out of a vector. And in Idris, we can make that type safe. So let's just call that vtake for vector take. And we take a natural number n and a vector of some elements. And now the cool thing is that in the type position, we can also do calculation. So if I want to take n elements out of my vector, I need at least n elements, but possible more. So I can just say n plus m elements. Since both are natural numbers, this will be positive, okay? And this vector can be of some type, okay? It could be integer, but we can be actually more flexible and just say, okay, some arbitrary type, whatever. And now I can return a vector of n elements of type t. So we can do the same again. We do an initial definition, and Idris will create the pattern matching of the natural number and my vector here. And it will create a hole here. So what we do is we can now do a case split on my natural number. And as I explained to you before, natural number is 0 or the successor of a previous number. And now we can ask the compiler basically to give us some information about this hole that we have here in this line. So what do we actually have to put there? So by hitting \t, we see here above this line the things that we have. So for example, we have a type t, we have a natural number m, and some vector of length m. And what we have to return, basically, what Idris expects, is this vector of 0 elements. So of course, the only way to fulfill this type definition is to return the empty list. And now in our second line, I have this successor of k, and I have my vector axis. And now I can basically do a k-split on that. And what you will see now is that Idris knows that this list, this axis must have been a concatenation, because my n is at least 1, and so this vector has to have at least one element. So Idris will automatically k-split on this concatenation. And now I want to take elements out of the vector, so I just take it and append it to some hole. And now I can do the same again. So I can, with \t, I can ask Idris to give me some more information about that. And this is all the things that Idris knows, basically. And so let's have a look at the whole first. So basically what Idris expects is a vector of k elements of some type t. I have a natural number k. And luckily I have a vector that has basically k plus some m elements. So what I can do now, of course, is just recursively call my method, my function here. So let's see if that compiles. Great, everything compiles, awesome. And now let's see if it, oh no, actually I wanted to do it here. So let's just see that not in the REPL but in the compiler. So let's just define some string. Let's call it these. And what I'm basically doing now, I take some elements out of some vector and just print them in a string, just to show you the compile time error. And show just converts the things into a string. And now I use my function, vtake, and now I can say, for example, take 3 elements out of a vector 1, 2, 3, 4, 5. And if I compile that, then everything works perfectly, okay? But now if I try to take 6 elements out of that vector and hit recompile, then I will get compile time error. Okay, so there's basically no way to do this in your program, but the compiler will force you to fix that bug, basically. So let's just undo that. And the last function that I want to show you today is a concatenation of 2 vectors. And let's just call that vconcat. And vconcat takes one vector of n elements of some arbitrary type t, and a vector of m elements of some arbitrary type t, and returns, of course, the concatenation, so it must be n plus m elements. So let's just do the same again. So we can provide an initial definition, and now we can basically k-split on this first list. Let me just go up a bit. You see all that, yeah? Okay. So let's have a look now. So I k-split on the first list, so it's either the empty list or the concatenation. And now I'm doing the same again. I'm asking Idris to give me some type information. And now, as you see, I need, as a result, I need a vector of m elements of some type. And these are the things that I have. So as you can see here already, luckily I have my y's, which is a vector of m elements. And now I can use a pretty cool feature, which is called proof search. So I can just hit \o and ask the compiler to search for a solution, okay? And if I do that, Idris will magically just find the solution of that. There's no other way to implement this here. Idris has all the information to just complete this implementation. And since I'm lazy, I'm just going to do the same here on my second, and as you can see, magically Idris will just implement that for me. So it's helping me in my laziness, basically. And to show you that this also works, let's just try it out. And yay, yippee, we concatenated the 2 vectors and get a vector of 6 elements of type integer. So that was my little introduction to Idris. I hope you liked it, and if you are interested, we have an Idris user group that we meet once a month or once every 2 months, and so yeah, please feel free to join.
Yes, thank you very much. So, do we have 1 or 2 questions?
I think over there.
Way in the back. Are there any real-world projects implemented with Idris?
That was the one question you should not ask. Not yet, not yet.
Okay, is there such a massive upside to dependent typing that it would be a good idea to implement something mission critical in Idris?
Yes, definitely. I mean, wherever you have like things that really have to be bulletproof, then this extra type safety can give you a lot more guarantees. So for example, like things like asking the head of an empty list in Idris typically will never happen.
Hello.
Hey.
I have a sort of like a basic question. How do you actually encode a value constraint on a type? So how do I say, well, the nat acts on the length of the vector and not anything else?
Yeah, that basically is, how can you say that? For example, in this case here, this n refers to this n, yeah, so they are not like independent of each other, and that's just part of the Idris compiler basically, that it figures that out. If you name them similarly, then it will...
Yeah, but how does the Idris compiler know yet this n is sort of related to the length of the vector and not, for example, if my t is an int?
Well, because the first position has to be the length. So a vector is just defined like this.
Okay.
So if we have a look at that, the first element is the length. So if you would switch that around, then Idris would not compile.
The last one?
That's more of a response to the previous question. So about mission critical code. I just want to tell a funny story about Java 6. I think it was until Java 6 where the collections.sort method had a bug and threw an exception for large collections. So that would not have happened with Idris. So yeah, that's it.
Okay. Thank you very much. So let's thank our speaker again. Yeah, that was the last talk of this evening. Thank you very much for joining us. It was very great. We had some great talks. We had a great location here, and it was very fun. So we might see us again in the next in this year again. I think we might invite you. The speakers. The speakers will be around if you want to just ask more questions in private.
Yeah, so Zipgate, thanks again for Zipgate for sponsoring that meetup. And they told us that we can stay some more time here, right? So you will not kick us out immediately. And yeah, thanks all speakers, and also Heiko for taking some pictures of the meetup. Thank you very much.
Yeah. All talks were recorded, and we will upload them and just share them in our meetups. Okay, thank you very much.